Good day, class. Today we're going to talk about our final lecture, composites. Recall yung ating three monolithic materials. You have your metals, ceramics, and polymers. Each of these materials have their own advantages and disadvantages. We just cannot get our desired properties by using just one type of a material. In cases we use composites. So the following objects shown in the screen are all composites or composed of composites. Artificially produced multi-phase material composed of two or more mechanically separable and physically distinct component phases. Breaking down the definition, 1. Your material should be artificially produced for it to be considered a composite, so it is man-made, not found in nature. Second, it is a multi-phase material. It is composed of two or more different materials, and the final result by combining of these two materials must have identical characteristics to any of the components, material 1 and material 2, in isolation. Our materials should also be physically distinct. Ibig sabihin, meron kang interface between the two different phases. Makita mo siya. And lastly, it is mechanically separable. The materials must have been synthesized separately. And we can separate the two materials mechanically. Gaano man kahirap gawin yun. So, hindi sila chemically joined or chemically bonded together. Screen is one of the more important composites in our lives. These are reinforced concrete. Reinforced concrete is a type of composite materials that we use for our structural applications such as roads, bridges, and so on. And it's composed of these components. You have your steel rebars, you have your large aggregates or your gravel, you have your small aggregates or your sand, and your cement. Combine this with water and you get concrete, reinforced concrete. So now let's test your understanding of composites. I'll be showing different materials on the screen and you decide whether they are composites or not. First, we have, reinforced concrete. So alam natin that reinforced concrete from the previous slide, this is a correct. It's a composite. Second, we have steel. Is steel a composite? No. Steel is not a composite because yung phases or yung steel or yung iron and carbon phases natin, they cannot be mechanically separated. And lastly, we have a carbon fiber mat. So carbon fiber mat, this is a composite. It's actually a laminate. So why do we use composites? So kanina nakita natin na pag hindi natin pwedeng gamitin yung three monolithic materials natin, the metal, ceramics, and polymers, we now use our composites. So what makes these composites, desirable? So these are just some few reasons why. First, we can increase the stiffness and strength of your material with an accompanying reduction in weight. So we're improving the performance to weight ratio of your material. Second, we increase the toughness. So this is especially good for those originally brittle materials. Third, we can maintain the strength of a material even when exposed to unfavorable conditions such as high temperature or a corrosive environment. So we can also increase the mechanical integrity of our product. We can modify the electrical properties, decrease the water absorption, decrease the thermal expansion, increase the chemical and wear resistance and corrosion resistance of your material. You can also increase the recyclability and the secondary uses of your material to reduce, we can reduce the permeability to gases and liquids and to improve the design flexibility of your material. So basically, we create composites just to improve our material. So the principle behind our composites is combined action. In composites, we're imparting the desired properties of two different materials onto one. natin na maraming uses yung composites natin, bakit hindi lang composites ang gamitin natin sa lahat ng bagay? The primary drawback of our ceramics is the cost associated with the manufacturing of it. So, it is highly costly because we're adding an additional manufacturing step to our processing. It is also energy and labor intensive, associated yan sa high manufacturing cost mo. Sometimes, when you combine materials, the interface or the bonding between your first material and second material is weak. So, minsan mahirap mag-bond yung mga materials natin. And lastly, some materials tend to be highly anisotropic. So, the property is dependent on the direction. So, let's say if we apply a stimuli on the transverse direction to that preferred axis, baka pwede masira agad yung composites mo. So now let's look at the parts of a composite. So a traditional composite has the following parts. First, you have your matrix phase. So matrix phase, ito yung tinatawag natin bulk phase. Ito yung karamihan ng material mo. Next, you have your dispersed phase. The dispersed phase, or also called as the reinforcements or fillers, these are scattered on your matrix phase. And lastly, we also consider the interface. The interface is the boundary between your matrix and your reinforcement. So shown here is an SEM of a fiber-imposed composite. So makita natin yung matrix natin, yung reinforcement, yung fiber, and yung interface nila sa matrix and reinforcement. So in composites, the bulk phase, since ito usually mas marami, this accepts the load over a large surface area and transfers it to the reinforcement, which being stiffer increases the strength of our whole material. Let's look at the different phases of our composite. First, you have your matrix phase. The matrix phase is also called your bulk or continuous phase. Since it is continuous, this binds to dispersed phases in place. And due to this binding, it transfers the stresses between your dispersed phases para equal yung distribution between our reinforcement. We can classify our composite depending on the type of matrix that we have. So first, you have your metal matrix composites. You have next your polymer matrix composites. And lastly, you have your ceramic matrix composites. So these composites just have the following monolithic materials as their primary or bulk component. As it follows, yung kanyang property, yung bulk na property niya is magiging same nung sa metal or sa polymer or sa ceramic na matrix mo. So for example, let's say we have a metal matrix composite. So ina-expect natin since metals are electrically and thermally conducting, a metal matrix composite will also be the same. Next, we have your dispersed phases. So we can be reinforcements, fillers, additives, etc. So this just enhances the property of the matrix. So ang primary role ni reinforcement or the dispersed phase is to enhance the property of the matrix such that matatanggal natin or mababawasan natin yung drawback ng material na yon. So for example, for metal matrix composites, what we want is to increase the yield strength, the tensile strength, and the creep strength, so that's why we add our reinforcements. In polymer matrix composites, since polymers are weak, we use our dispersed phases, let's say fibers, or fillers, or particulates, to increase the tensile strength, the yield strength, the Young's modulus, and the creep strength of your polymer. And lastly, for ceramic matrix composites, ceramics are strong, but they're brittle, so they're susceptible to fracture. So we add our reinforcements, our fillers, or dispersed phases to increase the fracture strength, to increase the life of our ceramic matrix. Morphology, there are two different types of reinforcements. First, you have your particulates. So particulates are particle-shaped na reinforcements. They have roughly equal dimensions in all directions. Example nito is gravel, sand, alumina, carbon black, and so on. Next, you have your fibers. Fibers naman your length is much greater than your diameter, tinatawag din natin itong mataas na aspect ratio, a high aspect ratio. So examples of this is your glass fiber, carbon fiber, and aramid. So aramid natin is yung thread or yung fabric natin in Kevlar. For our composites, different factors would affect the property of our composite. One, the properties of the constituent phases. So since dito nanggagaling yung property ng ating resulting composite. Next, the geometry and orientation of the reinforcement materials in the composite. This is especially important whenever we're thinking of anisotropic loading or anisotropic application of stimuli to our material. Since in some cases, let's say in one direction, your material or your composite can be strong against a force, but when you put it in a perpendicular direction, humihina siya. There's also the ratio of reinforcement to matrix in the composite. So, magkakaroon tayo ng sliding or ng adjustment ng property depende sa ratio of your two faces. And your composite property is also affected by what kind of reinforcement that we have. So, if you have a particulate or short-filled fibers in your composite, you're expecting your composite to be more isotropic. So, magiging invariant siya with direction yung kanyang properties. So, it won't be strong in one direction over another. On the other hand, if it is a fiber-filled composites, especially if yung fibers mo is aligned to one direction, we expect that your material will be anisotropic, meaning that it might be stronger in one direction than the other. For composites, the particulate phases is usually harder and stiffer than the matrix, and this restrains the movement of the matrix phase in the vicinity of the particle, increasing the strength of your material. So for particulate reinforced composites, the property of your material is governed by what we call the law of mixtures. So these two equations here, equation dito and ito, these gives you the upper and lower bounds of your property. So depending on the fraction, the weight fraction or the volume fraction of your reinforcement, magkakaroon tayo ng movement or ng adjustment in the properties of your polymer or if your composite. But makita natin, generally, the property of your composite is in between that of the reinforcement and of the matrix. So shown here is the elastic modulus for a material. Screen are two different micrographs of composites. Yung nasa kaliwa, this is cobalt reinforced tungsten carbide. So we usually find this in your cutting tools. So from the micrograph, yung white spots natin, this is your cobalt matrix. Meanwhile, yung medyo dark na gray natin, this is your tungsten carbide particles. This type of composite, we usually use this in our cutting tools. Since tungsten carbide is hard, pero usually particulate yung kanyang ating synthesis dyan, so kailangan natin siya i-bind using cobalt. On the right, we have the electron micrograph of carbon black in rubber. So this is rubber with carbon black. So carbon black mo dyan yung itim, and yung matrix phase mo is a rubber matrix. If you see, meron din tayong bubbles dyan. Those bubbles are air bubbles inside your rubber matrix. So ito yung micrograph usually ng ating tires. Ang ginagamit natin for kotse. Vroom vroom. So for concrete is a composite. It's composed of cement and of aggregates. You have your coarse and fine aggregates binded by water, and it has some porosity, meron siyang air. So next we look at fiber reinforced composites. So sa fiber reinforced composites, yung ating reinforcements now are fibers. This maximizes the strength, stiffness, or toughness value of your material while limiting the weight. So the design considerations here are your fiber face, fiber length, fiber orientation and concentration, the matrix in which our fibers are embedded in, and the bonding between your fiber and your matrix, or the interfacial bonding between them. Fiber-reinforced composites is that fibers are usually stronger and stiffer in their long aspect ratio form, and there is a high surface area to volume ratio between their fibers, meaning mas marami tayong interfacial bonding na pwede mangyari, mas maging stronger yung connection between your reinforcement and your matrix. But the weakness is, or the disadvantage of your fiber-reinforced composites is that fibers are usually weak in compression. So if you compress them along the axis of your fibers, you would lead to buckling. There's also poor transverse properties. So if you are perpendicular to your fiber axis, hihina or mahina yung material mo. And fibers tend to fracture in a brittle manner, which we'll know is bad because wala tayong warning sign before your material would fail. The property of our fibers in our composites is the length of the fiber reinforcements. There must be a sufficient length depending on the type of materials that we have in our composite, such that enough yung length ng fiber mo para ma-bear yung load na na-experience ng ating matrix. If it is too short, it might not be able to bear as much load, making it ineffective as a reinforcement. So we have different fiber configurations for our fiber reinforcements. We have your continuous and discontinuous fibers. So pag continuous yung fibers mo, usually ito yung mga mahabang fibers embedded in a matrix. If discontinuous siya, yan yung mga short fibers natin. It can be aligned or not aligned. So have your fiber rovings, your strand mats, your chopped strand mats, and surface veils, and other different configurations for our fibers. So now let's look at the role of the matrix in our fiber reinforced composites. So the matrix serves to bind our fibers together and acts as the medium in which an externally applied stress is transmitted and distributed between our fibers. This also protects your fibers from surface damage and or corrosion. And this separates fibers from each other and prevents the propagation of brittle cracks from one fiber to another since may space tayo between our reinforcements. So for fiber reinforced composites, we also have the following law of mixtures. So the law of mixtures here is the longitudinal and the transverse property. So for your fibers, usually mas maganda yung longitudinal property niya. So the longitudinal property is the property aligned with the fiber axis than the transverse property. And their resulting properties depending on the axis of loading is given by the following equations in the screen. So for now, hindi pa naman natin kailangan yung mga equations na yan. We have our structural composites. Structural composites are usually composed of plies or multi-layers, and this is used in applications that require structural integrity. So the properties of structural composites depend on one, the constituent materials we use to create our composites, and second is the geometric design of our structural elements. Kinds of structural composites in here we'll tackle two. We have your laminates. So laminates is composed of 2D sheets that have preferred high strength direction. So example of this is plywood. If you look at plywood, tinawag siyang plywood because it's composed of different plies of wood. These different plies of wood are aligned in different directions. You can have stronger bonded by, let's say, wood glue. We also have your sandwich panel. Sandwich panels are used in applications in we want low weight but acceptable strength, or pwede rin sa insulation and so on. So sandwich panels, these are composed of two strong outer layers separated by a layer of less dense material or core which has lower stiffness or strength. So an example of this is your laminated glass. So you have two glass panes at the outside and meron kang laminate sa loob. So depende sa material, minsan transparent plastic, minsan air. We're done with MatE 21. So hopefully, nakatulong naman sa inyo itong video series na ito. And hope you all are staying safe and sane. And I'll see you when we get back to UP. Hopefully sometime soon. Or not. I don't know. Goodbye. Thanks. Yes.